All right, welcome tonight to Module 3, Lesson 4. And our objective was to add fractions with unlike units using strategy of counting equivalent fraction, including sums between 1 and 2. This is going to be a lot like what we did the day before. We're going to still use models in order to make equivalent fractions. The essential question you need to think about is how can I use equivalent fractions to add fractions with unlike denominators? Think about that as we're doing the lesson. Now, let's take a look at our first example here. It says 1/3 plus 1/4. Now, let me get my pen. Now, if you notice, the first one to the left is a model of 1/3, and the one to the right is a model of 1/4. Now, they are flipped opposite for a specific reason, and if you remember in the last lesson, it's so that we can combine them to create equivalent fractions. Now, the first thing I'm going to do is instead of my thirds, I'm going to go ahead and take my lines from my quarters, and I'm just going to copy them straight over. Then I'm coming to my 1/4, and then I'm going to have to create thirds on this one. And if you notice, it sets up exactly the same array in both models. And in the first one, I can see that I have 4 that are shaded out of a total of 4 times 3 is 12. So I know that 1/3 is equal or equivalent to 4/12. And we're wanting to add that to, we have 3 shaded out of a total of 12. And if you just count up all the blue shades, we can see we have 4, 5, 6, 7. When we're adding fractions and we have the denominators are the same, we just add the numerators, 4 plus 3, which gives us 7, and the denominator stays the same, which would be 12. So we know 1/3 plus 1/4 equals 7/12. Okay, so now that we've done the first example, now we have a 1/2 plus 3/4. I went ahead and modeled them for you. I want you to go ahead and pause the video, try to work this one out yourself, and then start it back up. Okay, let's see how you did. Here's my 1/2. I'm going to take my quarters over to my other model. And on my 3/4, I'm going to take my 1/2. Now when we count them up, we can see we have 4, and 2 by 4s gives us 8 for our array, plus in our second model, we have 6/8, which that is actually equivalent to 10/8. Now, this here is a fraction that's greater than 1, and you're going to see in future lessons, I don't always require you to reduce them or convert them to a mixed number, but I want to just show you how you would decode this. Now this is 10/8. Now I want to make one whole. So if I took 8/8 plus 2/8, I would have 10/8. And 8/8 is the same as one whole. So we would have 1 and 2/8. Okay, in our next problem, we have 4/5 plus 1/2. So let's go ahead and pause the video. You try it yourself and then start the video again. Okay. Now, as you can see, first thing I always like doing my first model because this is our 4/5. And then we have our 1/2. We need to split this into fifths. There's 1, 2, 3, 4, and 5. Now for our 4/5, our equivalent fraction is 8/10 because we have 8 shaded out of total 10. And for our second model, we have 5 shaded out of a total of 10. When we add all the shaded ones together, we're going to get 13/10. Now, so we know this equals to 13/10. Now I like to break that down. We have the tenths, so if we go 10 over 10, that is equal to 1 whole, plus we'd have to add 3 more tenths to it to be equal. So this would be equal to 1 whole and 3/10. So you notice all our sums are coming between 1 and 2. So it's a fraction greater than 1. Okay, I'm going to go ahead and pause this video and go ahead and try it, and then we'll come back and check it out. Okay, so we have 2/3 and 3/5. Once again, just copying over, taking our fifths over to our thirds. Now my thirds, excuse me, my fifths here, I got to create my thirds. And you notice that this is doing nothing more than creating an equivalent fraction for us. And we can see this array here is a 3/5. So we know our denominators are going to be 15. Now the shaded, we have 2/5, so that's going to be 10 on this side. And over here we got a 3/3, so that's going to give us 9. So when we add them together, we're going to end up with 19/15. So we know 2/3 plus 3/5 equals 19/15, which is equal to 15/15, plus we'd have to add another 4/15 to it to be equal, which we know 15/15 is the same as 1 whole, so we have 1 4/15. All right, now we got 3/8 plus 2/3. Go ahead and pause the video and start it back up when you're ready. Okay, so this is our 3/8. This is our 2/3. I'm bringing my thirds over. I'm going to bring my eighths over. You notice this strategy is starting to get more difficult because how many I'm having to segment into. This is only 1, 2, 3, 4, 5. I need 3 more. There's 1, 2, and let's try this one for 3. Makes it hard to start counting them. But we know we have a 3/8. So we're going to have 24s as our denominator. And we have a 3/3, so this is going to be 9 24s. And over here we have a 2/8, which is going to be 16 24s. Which when we add them together, it's going to give us 25 24s. So we know this is equal to 25 24s. Which when we decode it, we know it's 24 24s plus 1 24s, which equals 1 and 1 24s.